Hi, friends. Aren't these beautiful? I think if I had to reincarnate, I'm not religious, of course, but if I had to reincarnate into an animal, I think I would like to come back as one of these spectacular large moths. Anyway, this video is, I hope, not going to freak you out because there were some experiments conducted in a day and age that really allowed us to learn a little bit more about physiology and the importance of certain organs that are, of course, neurosecretory and their relationship to specific behaviors. These beautiful moths that you see here, um, just before they emerge from the pupa, that is related to specific times of the day. Now, this little graph that you're going to see here, I'm going to go through it with you systematically. But Cecropia is the species name of the moth that was on the left a while ago because it feeds on the Cecropia plant. And then Pernii is the other one that was on the right-hand side. Now, before we talk about the study per se, let's just unpack the graphs first. So the first is that the y-axis is showing the number of individuals that eclosed. So this is pupa emerging into adult. The x-axis on these graphs tell us something about the time that this occurred. So if it is a white area, that's the daytime from 8 a.m. until about just before midnight. And then this shaded box here is in reference to really late at night. So after midnight, basically. Okay. So you've got daytime and nighttime, although this is like here, this is 8 p.m. Okay, so the colors are a little bit misleading, but the gray boxes are basically showing after midnight. Okay, so let's unpack this. So the pupa, or pupae, I should say, that were left on their own, nothing happened to them, just leave them on their own. So they were unoperated, and this sort of gives you a heads up that this is going to be about some aspect of physiology that maybe we no longer really do. But basically, they were left untouched. And you'll notice that this is a representation of their brain. And you'll notice that there is a particular peak associated with when most of the pupae would eclose into adults. So if you're a Cecropia moth, then there's a very good chance that you will become a beautiful moth emerging from your chrysalis in the morning, in the daytime. Whereas if you are a Pernii, that moth, you can see that they peak around just before midnight, so around after 8 o'clock, right? That's when most of them will eclose and emerge. Now, what do we see in experiment B? In experiment B, B for brainless. In experiment B, the brains of the pupa were removed surgically. Don't ask me how. And no, I don't intend to teach you all this skill. And no, I have not done so myself. And yes, I've entertained the thought of doing it in class, but we're not going to do that. So we remove the brain. And no, remember, these are actually quite large pupae. So it is actually not crazy to do this kind of microsurgery. So anyway, remove the brain. And what happened? You see that as soon as they remove the brain, when they actually eclose becomes quite random. So small numbers eclose pretty much consistently regardless of time. That probably tells us that there must be some relationship between the environmental cue, whether it's day or night, that the brain perceives that then triggers this particular eclosion behavior. Okay, let's do more. Experiment C, okay, was, and this is where maybe you all will freak out a little bit. Experiment C is where they took the brain and relocated the brain into another section of the pupa. So take the brain out from the head region of the pupa, which you can still section, by the way, and then put them in the abdomen region of the pupa. What happens? Well, you'll notice that, and this is within the species, okay? So Cecropia brain remains in Cecropia body, and Pernii brain remains in Pernii body. And you can see something very interesting. You can see now the cluster coming back. So it's not very random. Yes, it's not peak. It's not as high a peak as in experiment A, but it's sort of telling us that it's still going to be in the daytime for this species, and it's still going to be in the nighttime for this species. That tells us that in addition to the environmental cue, the brain, the location of the brain is not important, meaning to say that the brain is able to interpret signals in the environment and release chemicals that inform the animal that it's time to eclose. In other words, there is the environmental cue following a cascade of events that include the neurosecretory organ, the brain, which will release something into the hemolymph that then triggers this activity. Now, experiment D pretty much seals the deal. And this is those reciprocal experiments. You can probably guess that this is probably the most logical thing to do experimentally. In other words, take the brain, swap the brain. So the brain of Cecropia is placed into the abdomen of Pernii, and the brain of Pernii is placed into the abdomen of Cecropia. And soon as you do that, you will notice that the brain influences exactly when, because this time, which is associated with Pernii, is now exhibited in Cecropia. They will eclose in the nighttime. Whereas here it shows us that the Cecropia brain is telling Pernii to eclose in the daytime. How wicked is that? So I hope you take away some key messages that it is a complex series of cues that must be present in order for a specific and biologically significant behavior to occur. The environmental cue, day-night, the brain's ability to recognize that, the brain's response in secreting hormones that trigger eclosion, and the fact that the location of the brain is not as important as its ability to recognize and then respond. And then the hormones are circulated across the animal's body, allowing them to eclose. And there is some relationship between the brain of the species and the time at which they eclose. How cool is that?